Perfect complements are a little bit different than what we've seen in the previous two little clips about optimizing the consumer's choice of their bundle. What's different is that the marginal rate of substitution is either infinite or zero, or it's undefined at the corners. So you can't just set it equal to the marginal rate of transformation. So how should a consumer maximize their choice of bundle if they have perfect complements preferences? Well, one thing's for sure, we know that these are consumers who only want to buy the two goods in equal amounts. So the bundle that they would want to consume would have to be along this dotted line. Because anywhere else, they're consuming more of one good than the other. For example, over here, they're consuming more of good 1 than good 2, while over here, they're consuming more of good 2 than good 1. And the extra units of good 1 don't help. So this consumer is just as well off at this point as they are at this point. So they wouldn't buy this good unless it were free. There's no reason to get the extra amount of good 1 and waste money on it. Similarly, this point is exactly as good as this point. So there's no reason to spend money on this extra amount of good 2. So the best bundle for this consumer, when the budget line is this line here, is this bundle B. Now let's look at this utility function. Remember, their utility function is given by the minimum of Q1 and Q2. So this consumer wants to buy a bundle where Q1 equals Q2. So if we just plug that into the budget constraint, we get, instead of, remember, P1 Q1, the budget constraint is P1 Q1 plus P2 Q2 equals Y. Well, if Q1 equals Q2, then we have this equation. P1 Q1 becomes P1 Q2. So now you can just factor out the Q2, and so you get Q2 times P1 plus P2 equals Y. So if you solve for Q2, you get the optimal quantity of good 2, which is Y divided by P1 plus P2. Now this makes a lot of sense here. Think of this consumer is buying these two goods in equal proportions. So rather than just buying good 1 and good 2 separately, they're buying this composite good, which is comprised of 1 unit of each of the two goods. So what's the price of that composite good? Well, if the price of this first component is P1, the price of the second component is P2, well, the price of the unit altogether, 1 unit of each, is going to be P1 plus P2. So if you have Y dollars as your income, how much of the composite good can you buy? Well, you can buy Y divided by the price of the composite good, which is P1 plus P2. So think of these as left shoes and right shoes. P1 is the price of a left shoe, P2 is the price of a right shoe, P1 plus P2 is the price of a pair of shoes. So how many left shoes are you going to buy? Well, you're going to buy as many left shoes as pairs of shoes you're going to buy. And how many pairs of shoes are you going to buy? Well, if you're spending all of your money Y on shoes, you're going to buy Y divided by the price of a pair of shoes. So Q1 and Q2 at the optimum are going to be equal, and they're going to equal Y divided by P1 plus P2.